Okay, in this series of videos, we're going to take a look at measuring investment performance, and we'll take a look at some return measures and some measures of risk. And we're going to do all of this in the context of Excel, so let's get started here. We're going to talk about holding period return and returns in multiple periods. So first, a holding period return is going to be the rate of return for a given period of time. So this could be for a quarter, it could be for a year, it could be for a 5-year period, etc. It could be any range of time. It's not defined as a set interval of time. So let's take a quick look at this formula here. We got P sub T, so that's going to indicate the price at some period in the future T, minus P sub 0, which is indicative of the price at the start of the investment. And then we're going to add all of the cash flows between time period 0, or the initiation of the investment, and time period T. So if there's any interim cash flows, if there's any dividend payments, for instance, or coupon payments for a bond, or in real estate, perhaps you have some rental income or net operating income, which we'll get into later on in the course, we can add that in as well. So this numerator is going to be all of the kind of the positive cash flow, all the money that we make. Actually, hopefully it's positive. It doesn't have to be. We could lose money on an investment. That's certainly possible. So we're going to take all of that, add it together, and then we're going to divide that or scale it by our initial investment, which is the P sub 0. So there's a problem with this measure, this holding period return measure, and that is that it ignores how long it took for you to generate that return. Another way of saying that is the scale is a bit ambiguous. So for instance, if you had a 25% return on your investment, that sounds good, but if I told you it would take you 15 years to get there, that changes things dramatically. So a holding period return isn't tied to any particular frame of reference, any particular point in time or range of time. So it's not a great way to measure returns. There's some better ways that we'll talk about here. And let's look at these returns in multiple periods. The first one you've all seen many times, I'm sure, and that's the arithmetic average. The geometric average is another very common way of looking at things. The investment industry, anytime you look at a mutual fund and how they report returns, it's going to be on this geometric average kind of framework. And then we're also going to have this very common measure called the internal rate of return. It's ubiquitous in real estate. Everybody seems to use it, so it'll be important that we understand how to do that as well and what it means. So let's look at some examples here. As I've already mentioned, you've seen arithmetic average many times, and it's a very straightforward calculation. It's useful as an unbiased forecast of performance in the future. So this is one nice little thing about this very simple measure, is that we can look at the last 10 years, for instance, and if we look at that arithmetic average, we can say an unbiased estimate of next year's 1-year return would be the average that we've experienced over the last 10 years. So as an example here, we've got 10 years of a REIT index, and their returns are 16%, 9%, -8%, 33%, etc. So obviously, to get the arithmetic average, we're just going to add up all of those returns, divide by 10. In this case, we'd have 63%. Divided by 10, we'd have a 6.3% average. You could do this with a pen and paper. You can do this with a calculator very easily. It doesn't have to be a financial calculator. And of course, we can also do this in Excel. Let's just jump over to Excel real quick and see this. We've got the returns listed. We can just add them up, divide by 10, or equivalently, we could use an Excel function, the average function. And with the average function, I just want to highlight all of the cells, all of the things I want to take an average of, and I would get my answer of 6.3%. And I went ahead and took it out to 2 decimal places to the 1/100th of a percent level, and that would be my preference in any returns that you're reporting for the class. All right, let's go back to the slideshow and continue here. So we've dealt with arithmetic average. Let's take a look at geometric average. Slightly more complicated calculation, but in many ways it's more meaningful. So this calculation gives different information than the arithmetic average, and what it tells you is the return that you are effectively earning per period over the life of your investment. So again, if we have 10 years of a REIT index and we have those series of returns, what we're thinking about or what we're answering is, what rate of return would we have earned if we had our money invested all 10 years? What is the return that we're earning over that period of time? What return explains our ending account balance? So for instance, if we start with $1,000 and we leave our money in all 10 years and look at what we end up with at the end, we can do some math and figure out what one rate of return we earned over 10 years that gets us to the ending point. So that's what a geometric average rate of return is, and it's also a very closely related to the internal rate of return. So let's just look at, again, the example here. We've got that same schedule of returns, and we're starting with $1,000. So at the end of the first year, I'm going to have a 16% return on my money. My money will have grown by 16%, and hopefully it's very easy to see, especially with the $1,000 starting value, that's what's happened. We went from 1,000 to 1,160. That's a 16% return. So we start year 2 with that amount of money, and it's going to grow by 9% because that's our second year return. So if you look at my formula here, I've multiplied the beginning amount times 1 plus the return rate. So that gets me to my ending account balance at the end of year 2, $1,264.40. So I had a 16% return, a 9% return. Cumulatively, my money has grown by 26.4. So I already noticed that that's different than just the 16 plus the 9. We've got this notion of compound interest going on. And then the rest of these are just as before. The same formula is occurring each time. In fact, when I created this, I just copied the formula down. Maybe we'll take a look at that right now. So my ending balance is going to be the starting amount times 1 plus that return. And I set up my spreadsheet in such a way that I can just copy this formula down and it will work. And then if I double click on this, I fill in the rest of that column because I have something on the left hand side here. So I've just copied the formula all the way down, and we've got our ending account balance. This is the important piece of information here. Our account balance turns from $1,000 10 years ago to $1,689 at the end of 10 years. And the question is, what one rate of return explains how we get all the way to the end and making, in this case, a cumulative return of 68.926%. Well, that's what the geometric rate of return is. The easiest way to calculate it is to use a rate of return. Find the rate of return that turns our initial investment of 1,000 into a future value of 1689. So you've already seen this calculation. We're just solving for a rate. We're solving for an annual rate in this case. That's the periods that we're dealing with. So we've got 10 of those, and we just use the rate function, highlight all of our inputs, and we solve for it. Click enter, and we get 5.3827%. That is the geometric average rate of return. Okay, a second method to compute that return is to take the total return, in this case 1.68925, and to get that number, by the way, I'm going to multiply 1 plus the return for each year. It's a multiplication of all of these things. So 1 plus the return times 1 plus the return times 1 plus the return. And all of these returns are the returns for every particular year. So years 1 through 10. And instead of adding these things, like with an arithmetic average, we're going to multiply them. And that's part of why we got this term, the geometric average rate of return. We're going to multiply those all. And you can see that we end up with 1.68925. It corresponds to our ending balance if we looked at how $1,000 is going to grow. We're going to take the nth root of that number. So in this case, we had 10 years, so we're going to take the 1/10th root. I raise that to the 1/10th power. That's what this formula is doing up here. And my results, one more step. We need to subtract 1 to get to the percentage, and that again is 5.3827. So it corresponds to this answer we got here using time value things. And then lastly, there's a third method we could use, and that is to use a function in Excel called the geomean function. So that's what this cell is doing here. But before we can use the geomean, which is a geometric mean function, we have to transform or adjust the returns that we see. So what I'm doing here in this column is I'm adding 1 to the year's return, the corresponding year's return. So in this case I got 1.16, 1.09. This year we had a negative return, so my adjusted return is going to be less than 1. In this case 0.92. And again, I do that for all 10 rows, all 10 years of returns. I use the geomean function, and I highlight all of those adjusted returns, and then again I would subtract 1 to get the percentage return. This would be an incomplete answer. It's not 1.05%. This is saying that the geometric mean is going to be 1 plus the geometric average rate of return. So we need to subtract 1, and again you can see that this corresponds to the other cells. Notice what happens if I just take the geomean of my unadjusted returns, and I can almost guarantee that somebody's going to try that, and I will get the number error, and it's because the math doesn't work. You're telling Excel some confusing things. It's going to return an error function or an error message, and there's nothing that you can do to get that to give you an answer. You need to adjust or transform your returns and then use the geomean function. So we've already run a little bit long in this video. It's at a little bit over 12 minutes. I'm going to stop here, and we'll pick up with looking at components of returns in the next video.